Hi, hello. Now we will discuss about determination of the acceleration of free fall g using the motion of two connected masses. Using the motion of two connected masses. So this is the diagram. So this is the pulley, the smooth pulley. We take smooth pulley and we connect the two thread, one side one, another one side. So we connected it joined. This two thread is joined together. So we connected likewise the mass A and mass B. That is equal. Mass A 100 means mass B also must be 100. So equally we can put likewise. Then afterwards it can be accelerate, then we can add any one side little mass increased. Here mass 100 means mass B is 100 means mass A we add 10 gram or 20 gram something we add. At the time only it is be accelerated. So you arrange like that setup. Then what they are saying here, when mass A of mass A is released, it will fall through a distance h. From the distance h how much? So like that 1 meter you arrange distance h, the floor, and mass B of mass B will move upwards. Both mass will have an acceleration of A. The tension is, the sting is T. The tension means the sting. The sting is give opposite force. That is we say it is pulling force. Pull this mass. So it is a tension force. So that is the two masses it will be accelerated. So we use the Newton's law. So applying the Newton laws to mass A and mass B. Okay. So you see here ma g minus t equal to ma mass A accelerations. So you see this one. So F equal to ma. So mass A it is a acceleration downward. Mass A it is a accelerator downward. It is the more mass is there. Here more mass is there. So more mass it is comes down. Little mass it is goes up. So here you see there mass is more. So that is why ma g minus t. Minus tension is less force. Compared to this one, the tension is less. That is why I write which one the bigger value and lower value. So if it is comes downward means the mass is higher than tension force. So mag minus t equal to ma. The F equal to ma. The force means this is the force. If you are minus tension force, both it is accelerate equally. G equal to A. If tension force is not there, G equal to A. So that is why the force equal to F equal to ma. So mag minus t equal to m mass A accelerations A. So here you see the tension force B. So mass B it is going upward. So upward means the tension force is more. So this mass is the less. That is why I write here. So T minus mbg, it is upward acceleration equal to, if you are cancelled the T, we can get it G. It's the D accelerations, it is accelerations. So both is same. How much speed it comes down, that much it is speed it goes upward. So that is MBA, the equation 1 and 2. So after that we are using the kinematic equations. Kinematic equations ut plus of at square. Why we use kinematic equation means we want to find it acceleration how much. So that is we will use kinematic equations. S equal to S means h, height. You take it likewise. Ut plus of at square. U equal to 0. There is a initial speed. When the setup is arranged, first initially it is be 0. Afterwards only we release it is started to accelerate. U equal to 0. Then h equal to S equal to h. So h equal to of at square. What we want to find a equal to the 2, it is comes here, 2h by, it is a multiplication, so it is comes down, t square. A equal to 2h by t square. Now this two equation we will add, equation 1 and 2 we will add. So equation 1 is a MAGT, that is a equation 1, plus t minus MB. So that is this 2 I writing. Left side, what is the 2 is there, that is I write here. I wrote here MAG minus T plus T minus MAG is equal to, so right side what is there, MA accelerations plus MB accelerations, both I write here. So this equation you understand? I think, did you understand this one? So next one, so the t minus t is there here, here plus t is there, both we cancelled each other. Then after that you can get it MAG MB minus MBG equal to A. A will take common, the both A is there here, we take commonly, then MA plus MB, we write like that equations. So MAG minus MB equal to A, MA plus MB bracket. So the G is a commonly is there, we take outside, then MA minus MB G equal to A, MA plus MB. MA plus MB is there here. MA minus MB into G, because here G is commonly is there, we take out, and A into MA plus MB. So A value already we find it. We find it here, A value. A equal to 2h by t square. We substitute here this A value. A. So A equal to 2h by t square. So next step we substitute A equal to 2h by t square, G value. So now MA minus MB equal to K by t square. K means constant. The constant value means, this is the constant value, K equal to 2h MA plus MB by G. This all value, if you are these are constant value. Height is constant, mass is constant, gravity also constant, everything it is constant. The constant value K equal to 2h MA plus MB by G. Suppose if you want to find it, G means G it is goes here and K it is comes down. G equal to 2h MA plus MB K. So now we will find the acceleration due to gravity. So you see here, we want to find gravity. So gravity formula is this, MA plus MB. So mass, how much mass I take it, 1.195 kilogram or 119.5 gram. Mass B 0.995 kilogram or 99.5 gram. So gravity value we know, which is the constant, 9.8 meter second minus 2. Height I fixed it 1 meter or 100 centimeter. So okay, K value. So we need to find K value. So if we want to find the K value, then only we can find it the acceleration due to gravity. So K value, how do we find the constant value? We know the formulas, we know K equal to 2h MA plus MB G. So 2 I write here, h value 1 meter, then I write here, I wrote here, then mass A 1.195 plus mass B 0.995 by acceleration due to gravity, G value 9.8. So if you are multiply this one, we will get it K equal to 0.4469. Then this value we will substitute here. Okay, again. So G equal to 2h MA plus MB by K. 2 h value 1. Then 1.195 plus 0.995 by K value is 0. Here we find 0.4469. So we will divide this one, we can get it G equal to 9.8 meter second minus 2. In this way, we will calculate g value, acceleration due to gravity. And so you see the uncertainty error. Uncertainty error means absolute value. Absolute value means the device which is the measured, it is a lowest distance. The scale, suppose you take scale, the normal scale, it is, we will measure 1 millimeter or 0.1 centimeter. So that is the absolute value. Otherwise, absolute as uncertainty. So that value you take it. So in the watch, it is measured the low value 0.01. That is why I wrote here. Then measured value, I take average is 2.11. 2.11. So the value is 0.47%. It is a very lowest error. So this is, in this way we can calculate the acceleration of due to gravity using the two connected masses, free falling accelerations. So that part we finished. So this part is over. In this part we find it likewise. So after that we find it here uncertainties. So MA minus MB, you substitute the value, and also K by T square, you substitute the value. What is the value you get? It's interpretations and evaluations. You can write. So there is also same procedures. You will do likewise. If you know this one, you can do everything, the same procedures. And also you take readings likewise. There is a mass is 1.195. Mass B equal to 0.995. The difference between the two mass 0.2. The time, so how much it is accelerated. So mass A 2.18. Second time again I will take same reading 2.15. Then it is average. Then if a square means T square. If you are square 2.11 into 2.11, we will get 4.4521. So in this way you find it this tables. So this is the determination of acceleration of free fall g using the motion of two connected masses. Okay, thank you.